And welcome to the third and final day of peer review presentations for GEOG 596A, the Spring 1 term 2023. I'm Jim Detweiler, the faculty lead for the Geospatial Programming Certificate, for those who don't know me. I'll be the MC for today. And trying to remember how many presenters we have today. We have 4 lined up today. First, a few reminders. Presenters, you'll have 25 minutes to give your talk, followed by 5 minutes of questions. Audience members, if you have a question, please enter it into the chat box. You might consider typing your question into a separate text editor, then copying and pasting it into the chat box when the presenter wraps up so that you don't distract them during their talk. Presenters, please read the question out loud so that anybody watching the recording will know what you're responding to. And 596A students, we expect you to provide each speaker with some constructive feedback. Others who are attending are invited to do so also, and we'll post a link to the peer review form in the chat box. So without that out of the way, first up, we have Andrew Gerberry. Andrew, are you all set to go?
Yes. Yeah. Can you hear me okay?
Yes, I can.
Great. Let me get my screen shared here. Let's see. All right. And you see my presentation view, right?
I can. Looks great.
Awesome. Great. Thank you so much, everybody, for having me today. So my capstone project is all about creating a master plan for water providers, specifically also including a case study for applying GIS analysis for growth planning at Delco Water. Dr. Janoten is my advisor, and she has been awesome with helping me formalize this. It was pretty rough to start with, so we've come a long way. Just a brief outline of what I'm going to talk about today. So I'll provide a little bit of the project background, the research questions that I derived from that, my proposed methodology to address my research questions, the expected outputs from that, the project timeline, and finally a presentation venue that I hope to present at the end of this year. So just a little bit of background on this topic. Water is essential for life, for all life, and especially for human life. And as recently as 2010, the UN declared that access to water and sanitation are human rights, that everyone deserves access to this vital resource. However, it should be noted that physical presence is not the same as access. A water or sanitation service does not serve the whole community if it's too expensive, unreliable, unhygienic, unsafely located, among many other factors. So since really the beginning of time and humanity and searching for water, there's always been challenges to accessing water. And more recently, as water treatment has evolved, as water distribution systems have evolved, water providers have had to face rising challenges to providing clean, reliable drinking water to growing populations. Many regions today are facing increasing water scarcities, especially exacerbated by the effects of climate change. And this is more true for rapidly growing urban populations throughout the world. Every year sees an additional 67 million new urban dwellers, especially in developing countries. And by 2050, it's projected that global water demand will increase by 55%, while stream flow could decline by 10% due to climate change. While different regions will experience different impacts of climate change, overall, greater populations will be exposed to water scarcity, then will become more water secure due to climate change. These climate-related issues only worsen the existing issues that water providers face today, including population growth and economic demand, aging infrastructure, pipelines, lead in water service systems, and finding adequate source water to meet the needs of their population. So with greater demand and lower quantities of source water, some utilities may need to increase their focus on improving system efficiency, water conservation, or creating dual reticulated supply systems to include recycled gray water. So the map on the left shows projected regional increases in water withdrawal due solely to population change and economic development in the US. So this is not including climate change. And as you can see, there are some areas that are really expected to grow and develop and continue having these challenges. With the effects of climate change, overall, it is significantly higher, although some regions will see a little bit of a decline. As I mentioned, this is very specific to regions depending on the effects of climate change that they may see. So in this case, Maine and Florida may end up a little bit more water secure or withdraw less, to say, from this. But you notice that especially the Great Plains and Western United States will be withdrawing more water due to climate change. And this is factoring in, requirements for food, agriculture, population growth, et cetera. So planning for these challenges is a challenge within itself. And many water providers have developed a master plan to address specific changes in the region. A master plan can be broadly described as a dynamic long-term planning document that provides a conceptual layout to guide future growth and development. Since each region is unique and variables are constantly changing, each master plan and what it should encompass is very location specific. So after developing a master plan, some water utilities may choose to focus on specific scenario planning, disasters, drought, climate change, pipeline replacements. Again, it really just depends on that specific region. But it's important to emphasize that a master plan is not a one-time build. Rather, it's an iterative process. So water providers will need to revisit and revise their master plans regularly to adapt for changing variables and new information. So some of the challenges to building a master plan are, first and foremost, just a range of available resources. Water utilities come in all shapes and sizes, from the smallest villages in the US to large multi-state corporations. And even the small villages will have trouble, having available resources, funds, staff, et cetera, to be able to develop a plan for their challenges. Data quality is another one, especially with geographic information system data, computerized maintenance management system data. And in this case, I usually like to describe this to people as sort of the I in GIS. So not only knowing where all of the pipes in a system are, valves, hydrants, but understanding everything about them too. When was the last time this was worked on? What's the history behind this? Both of these things can be combined into a hydraulic modeling software that can model how water moves throughout the system and allow the water utility to plan future pipelines or understand how they need to move water there. And finally, focusing on water end use data. So understanding how and when customers are using water for their needs so that the utility can meet that. So you can imagine a very small utility having a lot of trouble having staffing requirements to meet these needs, or even having adequate data quality at all. Anecdotally, in my own work, we took over a small village in Ohio a few years ago, and the only data that they had available for their water system were hand-drawn maps from the 1960s. And that was what they used for many, many years to work on their system. Maybe at one time it worked and was great, but definitely not adequate for what they needed. So looking at all of those data sources, you can start to do some predictive analysis then on what the demands are going to look like, on which pipes are going to need replaced first, and prioritizing what work you're going to do. And maybe the ultimate culmination of a lot of these things is building a digital twin of the water distribution network. Digital twin is sort of a buzzword that I've been hearing for many years at conferences, and really just going back to the idea of a twin system, thinking about like the Apollo program when NASA, first went to the moon. Many of you may have seen the movie Apollo 13 and of course the actual events of Apollo 13. NASA built a physical replica of that module here on Earth, which allowed them to go through these scenarios and help those astronauts return safely. A digital twin is that same concept of creating an exact digital replica of the water distribution system so that you can plan for these scenarios, disasters, and things like that. You have to have really, really good data to be able to create that digital twin, because if the data isn't good, you can't create that twin. So that's a big hurdle for a lot of places. So from these, the research questions that I really want to answer are, what are the key components to a master plan and how should they be prioritized? How can a master plan be an iterative process, and how often should a master plan be revisited? And how can GIS be used to integrate projected population growth and development activities into a master plan and analyze its potential impact on an existing water distribution system? So to answer these questions, I'll have three key parts to my methodology. The first is conducting interviews with water providers. I'd like to get at least 5. Extend that literature review that I've already done and try to see what other people are doing. And finally, apply a case study at my employer, Delco Water, and study population growth and analysis and using GIS analysis. So from the literature review and interviews, I really want to figure out what all of these components to a master plan are. And this is the framework of how I've been thinking about this. So the blue boxes represent data sources. The orange is the analysis performed, sort of the landing place for all of these. And then the green are possible outputs or future points of analysis to derive from this. So thinking about data that is internal to a water provider, that GIS data of their water distribution system, that end water usage information, their maintenance management system data, combining those things into some kind of hydraulic modeling software, and then looking at population growth models, climate change models, and looking at the possible outputs of that. Through my literature review so far, most utilities have that have come up with a master plan have focused typically on one area of this, one particular big challenge for them. In the case of Tampa Bay Water, it was focusing on reducing groundwater extraction, and that was the focus of their master plan. So through conducting interviews and looking at further literature, hopefully I can get a really comprehensive list of what other people are doing to solve this problem. So then specifically at my company, Delco, Delco is located just north of Columbus, Ohio, and currently serves around 54,000 connections across 8 counties. It's about an 800 square mile service area, so it's about middle of the pack as far as water utilities go, especially in Ohio. We're located in a very fast-growing region right now, at least comparatively. So right now there's around 2.2 million people in the metropolitan area, and by 2050 that's expected to grow to 3.15 million. And talking about those future variables and changes, just last year it was announced that Intel would be building a very large chip manufacturing plant very close to our service territory. So things like this are constantly evolving and changing things. So Delco right now serves around 200,000 people in that 8 county service area. And like I said, we see a lot of very fast growth. So Delco, being a private nonprofit company, is sort of a unique position because we are not affiliated with a municipality. So we really don't have a lot of say in how growth or zoning happens. So we've had to be very reactive to growth. And our customer base is primarily residential, low density suburban. So one of the big challenges that we see are from large seasonal variation in water consumption, where in the wintertime, because people aren't watering their lawns, usage is much lower. But we've had to increase our plant capacity to meet the demands of summertime when our customers really want to be making their lawns that much greener. So based on some climate models of Central Ohio, there was a 2015 study that the Mid-Ohio Regional Planning Commission did with Delco's cooperation among the other regional water utilities called Sustaining the Scioto River. And one of the outputs of this was realizing that Ohio will likely experience an increase in temperatures and heat waves, which means lower volume and quality of surface water. And the utilities around here are very dependent on surface water because groundwater is not that abundant or of good quality. This also could mean more extreme weather events, which would mean damage to infrastructure, and then the increased economic burden of having to repair that infrastructure. So there's also going to be a disaster planning component to this. So specifically for Delco, this could also mean a huge additional burden from outdoor water use. As I mentioned, we already see a lot of seasonal variability in water use, and if Ohio's summertime is going to be hotter and drier, then that will introduce a lot more problems for Delco as people still want to keep their lawns green. But one of the challenges for us too is that people don't necessarily want to be told by their water provider how much water they can put down. They expect a certain quality of life when they come here. So it puts us in a little bit of a tough spot to plan for that. So the way that I'll look at this case study then for Delco, again, the blue box is representing data points, the orange sort of analysis points, and then the green are outputs. So population growth is probably one of our biggest factors that we'll need to take into account. As I mentioned, it's a very fast growing area, and we're going to have to develop infrastructure to meet those needs. So we're going to be looking at larger parcels of land that could turn into developments, Central Ohio population data models, and where this growth is predicted to happen. Also looking at historical development data, how fast growth has happened in the past and how fast we could maybe anticipate it to happen. Our GIS data, the water distribution system, and then that water end use data, understanding how water is consumed throughout the system. We'll compile all of this into a hydraulic model and then perform analysis to see where we need to install additional infrastructure to meet these demands. And then also look at that parcel data to understand where all of these demands are going to be happening, and using township growth zoning regulations and understanding how that development might occur there. But then also looking at the added variable of climate change projections and what that impact could look like on the water system at given intervals. And finally, all of that will be compiled into an interactive web map provided by, or GeoCortex is the third-party mapping application that we use. And all of that will be available to Delco staff then, so that it is easily updated, centrally stored, and so on. So this is just kind of an idea of what that map will look like. We've already started doing some of this analysis. And as I mentioned, looking at around 5 years, 5-year increments of growth. And then we'll revisit this every so often and see how we've been doing. That's part of the iterative process of this. So the expected outputs of this then will be, of course, the capstone project report with different chapters outlining the specific components of this, such as the Delco case study, and some added variables of where that growth will happen, what the effects of climate change will be, the effects of without climate change, the effects of including water conservation and without water conservation. And I just mentioned the interactive web map for the Delco case study. And then finally, a presentation, hopefully at the Water Pro conference in Colorado this year. So the timeline of this is that initial literature review, which we would have just completed, the project proposal, interviewing at least 5 providers, water providers, to understand how they built their master plans or how they would plan to build a master plan, compile a report of those findings, extended literature review, and then start building out Delco's case study by building out that hydraulic model, doing additional growth analysis, doing the climate analysis, and then finally presenting that capstone presentation at the Water Pro conference in September. And of course, ongoing, as I mentioned, there is the iterative component of this is really important, that we revisit and revise the master plan on an ongoing basis to account for variables. As I mentioned, the Water Pro conference is put on by the National Rural Water Association that represents over 31,000 utility system members. They're primarily smaller rural systems with fewer resources. So I feel that this is a really great group to present to, as they may be some of the ones that have struggled a lot with this topic. Just in my research so far, I've noted that a lot of the larger utilities tend to be ahead of the game with this and understanding that they need to be planning for the future. But that makes sense. They have the resources to do so, whereas these smaller systems might not. So that's what I hope to accomplish with this presentation. And I really appreciate your time today. Thank you.
All right. Thank you, Andrew. Nice job. So Beth kindly pasted the peer review evaluation form to the chat box for the folks in the audience who want to provide Andrew with feedback. While we wait for questions to come in, I had one. Andrew, you talked about wanting to talk to at least 5 other water providers to find out about their master planning. Did you have some sort of plan in mind for how you would go about recruiting those other water providers? What sorts of things you had in mind in terms of figuring out who to talk to?
Yeah, that's a good question. Just through my professional connections, I know of a few. I would ideally like to do some variations in company size, geographic location, just so that I'm not focusing on all the same types of utilities. So it really broadens it up. But I have a few in mind already that I should be able to get into contact with. But I'm also open to suggestions on ways that I can expand that too.
Yeah, I wasn't sure if you were looking for other water providers that were, similar to yours, or if you wanted to get some more variability in the kinds of providers that you talk to. I wasn't sure exactly what direction you were going there. Okay, looks like you've got a question from Fritz in the chat.
Yes. So the question is, have you thought about any user feedback and the ongoing update to your system after its implementation? Yes, definitely. So, one of the great benefits of having that centralized web map viewer is that everybody at Delco is going to be able to see that. And GeoCortex has some nice tools for collaborating where somebody can mark up a map, sort of like, ArcGIS portal or, other map sharing kind of things where they can make markups on there, share them with other people, have discussions of that. And then, we'll collaborate on that and revise the master plan as needed. Thank you.
Looks like you have another question in the chat from Ryan Baxter.
Okay, yeah. How available is parcel data in your region? In Pennsylvania, it can be very hard to get because it is controlled by each individual county. In general, do you anticipate any challenges with your data sources? No, you are very right, though. There is a huge difference in the county auditors in our service area. The more affluent, more populated counties tend to have a lot more readily available data that's updated. But so far, no, we have a pretty good relationship with them, and they all in recent years, well, there was one county that just recently got GIS, so that made it really easy to get data from them. But once a month, I actually update our data from them, just because, especially in Delaware County, our primary service area, there are so many changes, so it's tough to keep up with. But yeah, good question.
I had another question. You talked about that GeoCortex web application, and it looked like you anticipate that application providing information on population growth projections and climate change projections. Maybe you can talk us through how you envision someone using that application to look at those potential scenarios, how that would then modify or alter planning for a water provider.
Yeah. So how I envision this is that so because it's just a web map, GIS, it's going to be made up of a bunch of different layers. So I'll have layers on there sort of outlining these different scenarios. So in one, it will be projected population growth and showing those in 5-year increments, so that the map user can go through and look and say, okay, this is where these areas of growth could be happening in this time frame. And then looking at like the climate change component, have a group of layers showing water demand in each of our meter route districts, without the effects of climate change, just taking into account population growth, and then have another set of layers showing what that demand would look like with hotter, drier summers. So that's kind of how I envision this. Is essentially, we'll be doing the data analysis in the background, and then the results of this will just be a layer in this web map.
Okay, good. Any other questions for Andrew? All right. Well, thanks very much, Andrew.
Thank you. Thanks, everyone.
That brings us to the second presenter, who is Karch Chancellor. Karch, are you here? Looks like you're muted.
Is that better?
Yep, there we go.
Do you want me to go ahead and get started? I'll share my screen
sure.
here.
Why don't you share your screen so we can see your slides?
All right, so good morning, everybody. My name is Karch Chancellor. This is my capstone proposal. This will be crown scourge variability of South Florida slash pines and prescribed fire managed mesic flatwood systems. So some simple background information. The area of interest for this project is Southwest Florida. Just some background history of fire in Florida. Way back when, the cycle was generally anywhere from a 2 to 5 year cycle. This is lightning-induced wildfires across the landscape. So that turned into prescribed fire management for land managers. This includes agency personnel, scientists, and private citizens. So again, a lot of what that is actually trying to replicate the natural cycle for land objectives. These objectives could be fuel loading or reducing fuel loads, ecological benefits, i.e. for habitat, different species of animals and plants alike. Additionally, that could be actually trying to bring the landscape back into its fire-dependent nature. So what I'll be covering is under the Florida Fish and Wildlife Conservation Commission's properties, and this is specifically the Babcock Webb WMA located just outside of Punta Gorda, which is in Southwest Florida. So the FWC has a prescribed fire management plan. A lot of that basically entails what I described earlier, and that's reducing fuel loads, habitat ecological management for different species, plant and animals, as well as trying to bring back into the fire maintained system that depends on the fire itself. So the area of interest for me, this is the Babcock Webb WMA, and I took this picture this morning. It kind of gives an outline. This is Webb Lake, and off to your left here, you'll see that's a Messick Flatwood system that hasn't been burned in 2 years, and then off in the distance, it's actually burned 2 weeks ago. So I just want to provide this picture to kind of context what the area actually looks like. The area encompasses 65,000 acres approximately. We have some in holdings, out holdings, but it's roughly 65,000 acres. The property has roughly 60 burn management areas, and these can consist of areas that are anywhere from 400 to 1,500 acres in size. So when we burn here at this property, we're trying mostly ecological burns. And that's basically trying to reduce the fuel loading along with increasing the habitat. The palmettos, the cabbage palms, different species within there that are specific to Messick flatwoods and hydric flatwoods. So just a quick overview of what the extra area looks like. So as you can see by the scale, this is 12 miles across and roughly anywhere from 6 to about 8 miles high. And I'll bring up a map later that shows you the land cover types within the area, but most of this area does contain Messick flatwood systems. So Messick flatwood systems, like I said before, contain species like cabbage palms, palmetto species. More specifically to what concerns this project is the South Florida slash pine. South Florida slash pines are part of the Messick system. It's integrated. It should be anywhere from a 60 to a 70 basal area. Some of the systems within the actual park itself right now is somewhere around 100. But what fire is trying to do, what we're trying to do with fire on the system is create anywhere from a 60 to 70 basal area. This is trees per, basically a measure of trees per acre or whatever unit you want to use. And this basically was with the purpose of management for our focal species is bobwhite quail. And bobwhite quail require anywhere from, we call it the third rule. So third grasses, third overstory pine structures, and then a third forbs. And so that's what the biggest intent for our fire program is. So what I'll be asking in this project is, why is crown scorch happening? So in our burn program, we have fire prescriptions, and these fire prescriptions are before the fact of a fire, and it basically outlines the goals and objectives, the weather variables, and then our goals or objectives, one of those is reducing crown scorch. And so one of our metrics is below 50%. Crown scorch is often our goal. Depending on the actual type of vegetation we're dealing with, it could be higher than that or lower than that. But in the Messick flatwood systems themselves, we're looking for under 50%. And if we go above that, that's when we actually trigger our own review process, and we do a 2-week review automatically on every burn. And if we find crown scorch above 50%, we go ahead and do a 2-month review. And at that time we find crown scorch above that 75%, we're initiating a 6-month review. The whole intent behind that is to document it. So in the future, we kind of have some gauge of what happened. And we want to prevent that because a lot of our area, like I said before, is between 60 and 70 inches, or I'm sorry, 60 and 70 basal area per acre. And if we start killing these trees, we're going to be below that. And that's going to have some ecological effects that are not going to be productive to us and are benefiting focal species. So here's the diagram. And this is actually ponderosa pine out west. This isn't actually South Florida slash pine. But what you can see is the trees themselves. So during the fire, you have, well, there's technically 3 types of heat in a fire, but the 2 that are most relevant as far as crown scorch goes is radiative and convective heat. And so the radiative heat is obviously what you see there, and it's not direct flames, but it is enough heat to where crown scorch is occurring. So crown scorch, by definition, is killing of the needles due to a lethal level of temperature. And the radiative component of that is actually pretty high within our system. And the convective nature is not as high because the trees are spread out. And as you can see after the fire, and this is how we gauge things in the 2-week review versus the 2-month and the 6-month reviews, you'll actually see the buds and the needles, they will brown. The terminal buds will sometimes brown. And so that's why on the right-hand side, you'll see crown scorch versus crown kill versus crown consumption. So crown scorch, you'll actually have the terminal buds remain intact, and crown kill, you will not. And crown consumption is basically consumption of the whole tree. We very rarely see that. We actually very rarely see crown kill because the way we manage, and on the 2-year cycle we manage 4, doesn't allow for the field loading to get to that high. So, and I took this picture this morning on the right-hand side, and this is a pretty good example of crown scorch, and this is edge and crown kill. And on the left side of the right-hand picture is actually a tree. This was a burn that was conducted 3 weeks ago. And so the right tree there, you can see that it's seen crown scorch. And the left tree, you've seen that there is some browning, but it's overall maintained all of its greenness and its needles. And on the left-hand side is a pretty good representation of what crown scorch. So technically on the bottom left on the left-hand side of the screen here, that's technically still crown scorch because the terminal budding of the needles is still occurring, but not at a rate where you see on the right-hand side there. So what ends up happening to the trees here is they're actually pretty robust as far as prescribed fire goes. But if you get to a level where you're actually consuming the buds, or you're in a different type of season, like a dormant season or just before dormant season, they're not as apt to recovery from such things as crown scorch. And so ultimately that leads to negative effects in our land management plan. So what do I want to do? I want to study the effects of mechanisms by which crown scorch occurs on the Babcock-Webb WMA. So the metrics I'm going to use, I'll outline later, but just some overall objectives here is the creation of the crown scorch classifier, and this is for crown scorch and non-cloud crown scorch classification. So what I'll ultimately be doing is ground truthing areas where we've seen 100% ground scorch, and then I'll also be ground truthing areas where we've seen 0% ground scorch. And I'll be using that in Google Earth engine to classify imagery from 2013 to 2022 burns. So an additional metric I'll be using, variable, is going to be the water levels. And it's actually an uncommon opportunity to do this because the area we've actually contracted out water level monitoring for the system. And so this gives us a model for the last decade of what water levels, direct observations and interpolated data based on the Mike Zero modeling application. And so that's one of the variables I'm going to include, as well as the burn variables. These come from the prescriptions I was alluding to earlier, and these are documented on site when we're actually burning. And so temperature, relative humidity, and wind speed is going to be the variables most applicable to this analysis. And so for the classification, like I said before, this is going to be from 2013 to 2022. And this is an actual direct result of the Landsat 8 system, what I'm going to be utilizing for imagery. It was 2013 is right about where our burn prescriptions were actually changed, and it actually, it kind of just happenstance that the Landsat system was launched, the 8 system. And so integrating all the variable data into the random forest model. And I'm also going to discuss a little bit of logistic regression. It's still kind of up in the air, and we're in the infancy as far as the analysis goes. So I'm kind of torn between the two at this current time, but we'll see as we go into the future what's actually going to work best, what makes most sense for the analysis. And so the overall goals for this is to predict ground scorch. This is this is the main goal of this, is to improve the burn program here for not only just the area FWC, but also private land managers or private citizens can all benefit from this in the end. And I think it's going to at least answer some questions. Because a lot of just speaking to private landowners around here, they see similar effects. And a lot of it doesn't make sense because usually if you've been burning enough years, you figure out trends and tendencies. And sometimes you get these outliers and where we get, 4, 5, 6 acres or 100 acres of ground scorch, and it just doesn't make sense. So identifying that should hold value to people around Southwest Florida, specifically burn managers. So the additional goal is to identify variable importance. And so with the capacity of the random forest modeling through ArcGIS, as well as logistic regression, gives you variable ranking. And so we kind of get a gauge what's more important to the question we're asking as far as variables go. So methodology. So as I alluded to before, the supervised classification, I'm going to be using Google Earth Engine as well as the Landsat 8 system, which gives us a revolution of 30 meters by 30 meters. That's if you go out west of wildfires, crown scorch observes on a much larger scale, and here it's not as big. So like I said, it's anywhere from 400 to 1500 to 1400 acres per burn unit, and the areas that are scorched could be just 10 feet by 10 feet, or it could be as big as 100 acres. But unfortunately, to go back a decade, I have to use the Landsat 8 system because the NAPE imagery is every 3 years, which obviously gives you a better resolution, but unfortunately logistics just won't do that. So we're going to have to use the Landsat 8 system. And so the crossfires through the GE will be used for classification of all the imagery from the burns identified through the prescriptions for the last decade. So like I said before, the water level data is actually monitored on site and has been by the contractor for over a decade. And we'll use the Mike Zero modeling software that gives us, it'll actually give us anywhere within the boundaries of the actual park, you can get at any point in time water level data. And this is plus or minus really anything you want. If you baseline to 0 or above ground or below ground, I'm going to use above and below ground because it just makes more sense as far as trees go, because this is a mesic flatwood system. Mesic basically means it's halfway between xeric and hydric system. So it sees hydro periods. And so the ability to gauge above or below ground is going to be important for this analysis. So additionally, I'm going to use the NRCS soils data, and here is a picture of our FNAI land cover, Florida's Natural Area Inventory, and this is just your basic land covers. As you can see here, the mesic flatwoods encompass a lot of the park, and then you've got your hammocks and other things that represent less by area. There is also hydric flatwoods in the system, but like I said, mesic flatwoods contain most of the actual area, and then pines. Besides the hammock, the slash pines are basically going to be throughout the park in different densities. But in the mesic flatwood systems, like I said before, between 60 and 70 basal area. So the methodology with the weather, like I alluded to before, was wind, temperature, and relative humidity. And on the right here is the fire triangle, and this is how fire. You need the 3 components of the fire, and so wind, temperature, and relative humidity in prescribed burning is the most applicable measurements because it affects the fire the most. Wind, relative humidity is one of our big ones down here, and we actually use it to our advantage a lot, but a lot of times we have instances where the relative humidity might drop 20% below than it was anticipated to be or forecast to be. And so asking the question, we have that boots on ground measurement. We have the anticipated forecast. Is there somehow a relationship going into this, that shows us that there is crown scorch beyond what we would have expected because 20% reduction, what is actually supposed to be forecast? We're going to ask that question. And so the random forest modeling, so this is applicable to this analysis because it can use categorical continuous variables, which will be encompassed in a lot of the variables in its predictive nature, as well as variable ranking, like I alluded to before. And so it's going to give us basically a prediction of, into the future based on variability within the variables themselves, as well as give us based on the data that we've put into the analysis, the ranking, what's most important. And I wanted to touch on the logistic regression or the binary regression. It also provides a predictive nature on the ability for variable ranking. I was consulting Dr. Taylor. I don't know, he should be here. The simplicity might make more sense, but as it exists now, I think the analysis done by the Random Forest, we're kind of torn between, do I have enough data basically substantiate my use of the Random Forest modeling versus the logistic regression. And we're not quite there yet because I have to go through all the prescriptions during this process and identify how much data we actually have. And I think at the end of that time, I can actually gauge, you know, which type of analysis would be most beneficial. And so for my timeline, pretty self-explanatory. A lot of this is actually going to be taking, just identifying the weather variables. These prescriptions aren't digitized, so what they're basically packets that have about 20 pieces of paper in them, and I have to go through every single one. And so for just a rough example, we burn 22,500 acres a year, and roughly that's anywhere from 30 to 50 burn units. And so it's a lot of paper to go through, and that's going to be a lot of the time there. And additionally, the Mike Zero water modeling analysis, once we identify applicable areas that we have Landsat 8 data for that doesn't have cloud cover or any other things that are making the imagery unusable, that's when we'll go into the water modeling and figuring out what the water's level were at those applicable points. Everything else beyond that is pretty much plug and play, putting it into the forest analysis or the logistic regression, whatever makes sense at that point in time. Then completion of the final report. And then right now as it exists, there's not a date for the conference I want to utilize. It's a fire conference in Southwest Florida, and it makes the most sense for me to present this to the professionals that would be most useful to. So they're going to give me a date somewhere around June or July when they actually finalize their plans. So the value, as I said before, the private citizens around here, they burn almost as much as we do. It's not a lot of agriculturally based stuff like you see in Georgia or North Florida with the longleaf pine systems, but they burn because the improved pastures of the cattle or clearing field loads, because when a wildfire does happen around here, especially this time of year when it's so dry, they tend to take off pretty quick and they're hard to contain. So private citizens and understanding the systems around it holds value. Agency professionals, especially the Florida Forest Service, the U.S. Florida Forest Service, Fish and Wildlife, Department of Environmental Protection, this all holds value to them. The data will be shared with them. They all work around prescribed fire in a lot of capacities on a day-to-day basis. Research scientists, and then field scientists. Field scientists more of your private company-based scientists that outsource burning. We actually outsource a little bit of burning here on Webb, and this obviously holds value to them to know the cause and effect of crown scorch so they can prevent it into the future. So for me, this holds value professionally because it has a direct impact on my job. My specific job here, I'm a wildlife biologist on the Babcock Webb WMA. And if we can figure out the mechanisms why crown scorch is happening, we can build our prescriptions or build new prescriptions. So when we prepare or plan for these prescribed burns, we can hopefully isolate the mechanisms by which so we can prevent it or not burn at all. It could be different ignition patterns, or it just helps us take a good long look at the program itself so we can avoid such things. And then personally, this holds value to my career. Obviously, gaining a master's in geographic information systems is going to be pretty exciting as well as professionally valuable going into the future. So my anticipated results, and this is just based on a few observations. There's a few pieces of literature that alluded to this, but they suggested further research. And so what I'm basing this off of is what I see in the field. And so we see hydro periods and water level has to do, all right, basically the evapotranspiration rate, the depths of the tap roots of these systems, or the trees themselves within the systems, are making these trees more or less moist. So the fuels or moisture is higher or lower because of the water table. And I think that will have the most impact as far as the variable ranking, and obviously the weather ranking. Like I said before, if your wind picks up, you're adding more oxygen to the fire, or if your relative humidity drops below 30%, then you're going to see drying out of fuels, intense fuel or intensity of fire increase, and just things like that. So as compared to the soils and land cover variables, I think these are going to hold more significance. With the soils and land cover being somewhat significant, but the areas we do burn are primarily the mesic flatwoods. So this analysis might not be able to see that necessarily. So a hydric versus a mesic flatwood system. And then the soils themselves, it's pretty sandy here, and the elevation, if you gain or lose a foot across a mile, that's pretty much considered a hill for this system. So we don't see a lot of elevation changes, and along with that, and associated with that is the soil. So we don't see a lot of variability in the soils. So I don't think that's going to hold too much significance as far as the results go. But that's it for this. And is there any questions?
All right, thank you, Karch. That was a fascinating talk. Really enjoyed it. Questions for Karch? Looks like you've got one in the chat from Fritz.
Let's see. Let me pull this back up. I'm sorry. Sorry, give me 2 seconds here.
Yeah, take your time.
Okay.
Let you read Fritz's question so that we know what you're
Oh, you want me
to.
to, sorry, you want me to read it out loud?
Yeah, please.
Oh, I'm sorry. A very
The
practical
chat won't
capstone.
show up on the recording.
Oh, I'm sorry. A very practical capstone project. I may have missed this in your talk, but this seems to be rather complex yet thorough modeling application. If this application is distributed to others, who is your end user and how well prepared would they be able to navigate through and understand your system? So the intent behind this is directly tied to the goal. So I did this for a reason, as far as this being able to be digested by private land owners, agency professionals, and scientists alike. So when I present this, in the end, I want it to be understandable. So associating it to land cover types, associating it to prescribed burns in the context of maybe using examples as far as you actually work through an example. So you're burning 1,000 acres and it has this type of fuel loading and stuff like this. I think that's going to be a way to explain it better. That's just the capstone project final professional conference. I think I'm going to have to take a good long look because it is very complex and I don't necessarily know the answer how to actually in the final proposal do this yet. Dr. Taylor alluded to putting variable importance graphs, things like that, just and making it, I think the more visuals, the better it's going to help, basically. If that makes any sense, but there's a lot up in the air. And I'm probably not answering it to the best, but that's kind of where I'm at right now. So I've got another one here. It's pretty interesting to see fire mitigation in an area that ignorance to the reality of Florida. Has climate change added more variability in how these crown burn prescribed burns behave? Was there agreed upon system in place, say 20, 30 years ago, that is now becoming more out of date? Or has the system always had flaws you intend to investigate? So it's actually, so climate change, yes, we have seen a lot of change, especially in the hydro periods. And what's interesting that you say that is across this decade that we've monitored the water level, we've seen an adjustment not only in length, but seasonality of hydro periods. So we can't necessarily conclude that it is climate change, but there is something going on. And in addition to that, Highway 75 borders our property. Highway 75 is a major highway system, north-south thoroughfare. And what ended up happening when they built that system is it basically built a dam. And we used to have water run north to south through the system. And what happens now in different hydro periods is it get caught in this by Highway 75, or it gets drained depending on where you're at in the property. And this didn't used to happen before. So 20, 30 years ago, the water used to all flow north to south. And now, because of Highway 75 and other urban projects, it actually part of the system flows north and part of it flows south. And then we have Highway 75. So the water flow across the area is extremely complex. And I think that's going to be one of the biggest influences on what we see. And again, I'm just doing water level per burn. So we're not necessarily going to be asking that question right now, but I think this will give insight into what we're going to do in the future as far as analysis goes, but it also might give us insight into the past. So like you were saying, 20, 30 years ago, even that short amount of time. And I've even seen it to where we have maps that were about 100 years old. And I have a couple here that we've geo-referenced, and it shows completely different land cover types just because of the water flow. And this is when Highway 75 wasn't there. So we are seeing causes like, the urban environment expanding ever eastward, as well as climate change. And it's can't necessarily say that it is that causing the crown scourge, but we can probably hypothesize it and test it pretty readily.
So I had a question, Karch.
Yes, sir.
To what extent do you think your results will be transferable to other parts of the world? Your area is very warm and humid. It's a flat topography, as you noted. So do you think your results will be pretty much dealing only with your area, or can others in other parts of the world learn something from it?
I would definitely, so the way I would do it is just by the link cover type. So when they delineate these wetlands in the FNAI, Florida Natural Areas Inventory, they're very specific on what they're delineating as far as, like a target indicator for Mystic Flatwoods in Southwest Florida, or Mystic Flatwoods in South Florida in general, is the South Florida slash pine. And so similar species, I think, and similar delineating characteristics will definitely be applicable across the board. We're pretty, like you said, pretty hot and humid, and that's the latitude that carries across the world. So I'm sure there's other systems that could benefit from this analysis for sure. And the similarities would be with the species themselves. And I don't necessarily know about the water flow, but just because the specific system I'm studying it's not natural anymore. But that would be something that would have to be highlighted and then kind of understood before you try to transfer this analysis to something like that. But I think as far as land cover and how you would characterize that could be applicable to other systems, especially across similar latitudes.
Good, very good. Any other questions for Karch? All right. Well, again, thanks for a very interesting talk. Good luck on your project. That brings us to our next presenter, Pallavi Rao. He's going to talk to us about crime in DC. Pallavi, are you ready?
Yes, hi. I apologize ahead of time for my voice. I have lost it a little bit.
That's all right.
I hope I can do this the right way. Yes, I can. Perfect. Okay, good afternoon, everybody. My name is Pallavi Rao, and my project proposal is spatial and temporal analysis of violent crime in Washington, D.C. for the year 2021. I would like to thank my advisor, Dr. Gregory Thomas, for his guidance throughout this course, also his patience. I will be covering in this presentation the background, literature review, goals and objectives, methodology, relevant stakeholders, anticipated results, and project timeline. So I'll give you a little bit of the background about Washington, D.C. Washington, D.C. is the capital of the USA. It was founded in 1790 by President George Washington. It is situated at the Potomac and Anacostia rivers. Its geographical land area is 61.4 square miles and water area is 6.9 square miles. Washington, D.C. has 131 neighborhoods, which are unofficially defined by the Office of Planning. DC is culturally diverse with about 170 nationalities and ethnic groups. It borders with the state of Virginia and Maryland. Now we will discuss a little bit of the background of crime in Washington, DC. Crime has existed since dawn of time. Crimes can range from minor offenses like traffic violation or misdemeanors to more severe crimes such as theft, assault, and homicide. What is violent crime? National Institute of Justice has given a very simple definition to violent crime. It says in a violent crime, a victim is harmed or threatened with violence. Violent crimes include homicide, sexual abuse, assault with dangerous weapon, and robbery. Violent crime is a significant safety concern in urban areas across the United States, and Washington, D.C. in this case is no exception. Crime in Washington, D.C. peaked in the early 1990s when it was known as the murder capital of the country. Although violent crime has decreased significantly since the 90s, but the city still struggles with increased violent crime. Washington, D.C. has one of the highest violent crime rates among major cities in the US. As you can see, it is 163.5 per 100,000 residents. There are several factors that contribute to the problem of violent crime. One is poverty and inequality. About 16.5% of the population in DC lives in poverty. DC has one of the highest rates of income inequality in the US, which is related directly to high crime rates. Second is access to guns. I was actually very shocked to learn about how much gun crime there in Washington, DC. Washington, DC has one of the strictest gun laws in the country, which aims to reducing gun violence and promoting public safety. However, neighboring states such as Virginia and Maryland have fewer restricting gun laws, which makes bringing firearms to DC illegally very easy. According to the Metropolitan Police Department, which is Washington, D.C. Police Department, most guns used in homicides are not registered in the DC. The third is racial disparities. When people are treated differently because of their race, it can cause anger and anxiety, which can directly result into making people commit crimes. Now, I was wondering that what happens when these crimes are happening. I went and did my research and I found that there are a lot of crime prevention initiatives taken by MPD in DC. And the first is all hands on deck. So what all hands on deck is, it's an initiative taken by the chief of MPD by putting more officers on patrol and engaging in one-on-one interactions with residents, so the residents feel safe in their neighborhood. And the second is Building Blocks DC. They have a section called the Office of Gun Violence Prevention, which is implemented to strategize and take initiative to prevent, reduce, and gun violence in Washington, DC. The last one is DC Office of Neighborhood Safety and Engagement. It was created to address violence in the district while assisting families dealing with the grief and trauma caused by these occurrences. Now we will dive into literature review. The literature review that I have reviewed so far supports the documentation of spatial and temporal analysis of violent and property crimes, although I'm focusing on violent crimes, so I only looked at majority of the violent crime data. The first study that shows here is a temporal and spatial analysis of homicides. This was performed in Recife, Brazil. And I find it very interesting throughout my literature review, not just this particular one, that a lot of these studies were performed in Brazil or in Asia. And of course, there are some in the US, but not as much as I wanted to see. So in this study, the first one, in Recife, Brazil, the goal of this study was to see if there is temporal variation in homicides, which taking into account seasons, months, days of the week, and time of the day. And is there a difference between the spatial patterns spatial patterns of homicide when we consider seasons, months, days of the week, and time of the day? The result shows that there are no statistically significant increase in the season and months. However, there are statistically significant increases in homicide during the weekends and evenings, which is very interesting because Recife, well, let me finish this line, then I'll explain more. This study also used temperature aggression theory and routine activity theory. So temperature aggression theory is relevant when we have a difference in temperature during the year. Recife is located near equator, and the temperature is tropical climate throughout the year. So it was not quite the relevant theory. Although the routine activity theory was very effective for this region because they saw that people's routine changes during the weekends and evenings as they want to go out or they have planned, they are away from their safety zone. The second theory the second literature is the spatial and social patterning of property and violent crime in Toronto neighborhoods. In this, the authors use spatial statistical analysis to examine the concentration and dispersion of criminal activities and the relationship between crime patterns and socioeconomic characteristics of neighborhoods, offenders, and victims. The research performed by the author here also explains that crime is not randomly distributed in space, but concentrated in areas with lower socioeconomic status. Then I moved on to another literature about gun violence because it's very high in DC. I was very much interested in knowing what's out there. Majority of the literature available talks about the economic cost of gun violence in Washington, DC, which I have included here. It explains that majority of the homicides that happen in DC involve guns. Gun violence and violent crime in a community directly affect the economy by lowering property value, and it can also affect the business activity. And another good fact about gun violence is that it cost Washington, DC $1.53 million US per homicide shooting, and it cost them about $2 billion US yearly, which was quite significant, I would say. And I will continue with literature review. And next, I looked at routine activity theory, which was extremely interesting. Routine activity theory is a criminological theory that explains how crime is a function of three elements: a motivated offender, a suitable target, and the absence of a capable guardian. Routine activity theory suggests that crime occurs when these three elements converge in time and space. Cohen and Nelson are the authors who originally talked about routine activity theory, so I have taken it from their literature. Another one, it says that researchers have also analyzed temporal and spatial crime patterns in Campinas, Brazil. Like I said, they have studied a lot of Brazil. Considering the routine activity theory's relevance. The author suggests that routine activity theory has limitations when explaining all the crime occurrences. The authors also demonstrate that it is essential to understand the local culture to understand the crime pattern when using routine activity theory, because every culture has a different way of moving around day-to-day activities. It's not same, so it's very, very important to understand which local culture we are studying about, which country, which city, I believe. Another one is crime pattern theory. Crime pattern theory suggests that the offender commits offenses in areas that are already known to them, so they're aware of them. The first literature listed under crime pattern theory suggests that criminal behavior is not random, but follows a pattern. Therefore, researchers performed an analysis demonstrating that repeat offenders commit offenses at similar times of day and week. The result shows strong temporal consistency, meaning offender commits their crimes at more similar hours of day and week than expected. So goals and objectives. So my overall objective of this project is to examine the violent crime incidents, to perform spatial and temporal analysis to focus on answering the following questions. What type of violent incidents occur most frequently? Where are the crimes occurring? Which census tract, neighborhood cluster, or police service areas are disproportionately affected by the violent crimes? When do the violent incident occurs? For example, the time of the day and the day of the week. What are the socioeconomic factors that influences these crimes? My study area consists of 179 census tracts in Washington, D.C., which fall into 7 police districts. Each police district here falls into 7 and 9 police service areas, which are quite relevant when I will be taking the data for the police service area specifically, which is available as when we discuss the data part, which is available for the crime data on DC open data. The population of Washington, D.C. is 689,545 with the density of 11,281 residents per square mile. Poverty here is 16.5% of the population that I have already mentioned before. I will be taking data from year 2021. There are about 4,090 plus incidents of violent crime alone. Violent crime includes assault with dangerous weapon, homicide, robbery, sex abuse. And the bar chart that I have included is from the DC crime cards that I just put it here for information purposes. I will be taking socioeconomic data of income, poverty, age, gender, and race, ethnicity. Boundary data will also be taken from the open data, Washington, D.C. boundary shapefile, census tract shapefile, and police service area shapefile. My data sources are violent crime incident data, and the boundary shapefiles are all coming from opendata.dc.gov, although it is also available on E3 Atlas. I hope I'm saying it right. Yes. Socio-demographic data will be coming from the Census Bureau website. And yeah. So analysis methods. I will be performing spatial and temporal analysis on violent crime in Washington, D.C., and I'll be performing hotspot analysis where a crime hotspot is generally defined as an area which contains dense clusters of crime incidents. It is a technique used by law enforcement agencies, criminologists, and researchers used to identify areas with high crime rates and deploy resources more effectively. Hotspot analysis involves creating a map of crime incidents and then applying a spatial analysis tool to identify areas with statistically significant crime concentrations. Next, I will perform a regression analysis to analyze the relationship between crime rates and socioeconomic factors such as income, race, age, and ethnicity. I will also be performing temporal analysis on crime data, which involve examining the patterns and trends of crime incidents over time. In my case, I will be, because I'm not using multiple years, I will be using time of the day or day of the week. And I also will be performing spatial analysis on the use of guns in violent crimes, especially for homicide, because as I was looking at the data, more than 80% of the crimes were committed, homicides were committed with guns. So that would be interesting to see. I will be using MGIS Pro, and for some of the statistical analysis, I will be using Tableau. The challenges and limitation for this project is data availability. For time series analysis, it would have been very interesting to get a variable where there is time available during the day, because it is not given in the form of when the victim is, when the crime has been committed, but when the victim reported the crime. So it's interesting because a police officer is recording the crime, so it is given based on the shift of the police officer and the time it is recorded, not necessarily when the crime occurred. So it's interesting. So that is one of my biggest limitation here. Another challenge that I am facing is that total number of violent incidents are not same in all DC official location. What I mean is, if I go onto open data, just a homicide, I have the homicide number memorized. It shows me 224 homicides. Although other places it's showing me 222, and 226 is shown on Metropolitan Police website. So which is interesting, but I'm gonna go with the number provided by the open data. Violent crime incidents are not always reported, especially sexual assault, which is, I think, very common. I've read different articles that talks about that people are ashamed, or they are afraid and they do not want to report. So that number is not always true, but we have to go with what's available. So the relevant stakeholders are law enforcement agencies. They use this data to locate areas with high crime rates, track patterns of crime, and create strategies to prevent and decrease crime. Another one is policymaker. They use this data to create effective crime prevention policies and monitor the success of current policies and programs in criminal justice reform. Real estate agencies, Zillow, Trulia, Neighborhood Scout, they share crime information around the house that they are selling. General public is a relevant stakeholder as well. They can use the information to monitor crime trends in their communities to make informed personal safety decisions. Anticipated results are better understanding of the patterns and trends of violent crimes, identify hotspots of violent crime in relation to socioeconomic factors, and identify temporal patterns of violent crime. Again, the day of the week and the week of the, I think it's the time of the day and the day of the week, I'm sorry. Okay, so project timelines. So I have not included this course in here. So my phase one is from April, where I will collect and process data. The phase two will be performing spatial analysis, which is in May. Phase three will be performing temporal analysis, and phase 4 will be interpret, and then phase 5 is Geog 596B course, where I will be writing and finalizing project and presentation. However, the presentation venue has not been determined yet because I live in Switzerland. I'm trying to figure out if there is something during my timeline. So I'm still working on that. And thank you for your time. Please let me know if there are any questions.
All right, thank you, Pallavi.
Thank you.
Looks like you've got a question in the chat already.
Yes, let me get out of this sharing screen. Okay. Okay, I will read the question. Hi, Pallavi, you did a great job. I wouldn't have known you lost your voice if you didn't say anything. You mentioned that you would not be using annual information. Did you have difficulty locating this information? Is it not out there? I think day versus night is a great temporal distinction. I also wonder about comparing COVID shutdown years to the overall trend or something similar in terms of years and what kind of information one might gain from this type of analysis. Hi, Carrie. Thank you for asking this question. Honestly, first I was thinking of doing the comparison between years, but then I decided to stick with year 2021 because I don't know, I wanted to keep it very concentrated for 1 year, although I might take into suggestion comparing it with another year during the COVID shutdown. However, I did literature review of a study done about COVID-19 impact in Chicago. And it was very interesting. And I was thinking of doing that, but when I looked at the data has not changed very much. So I was like, why am I using 1 year over the year? And I picked year 2021 because it is after the COVID and I wanted to see if that has a huge impact on it. And I don't understand when you say, you mentioned that you would not be using annual information. I'm sorry, I didn't get that part. But I hope I answer your question.
I suspect Carrie meant using multiple years instead of just one.
Okay. So yeah, I decided to go within a year to see, although when I was thinking about time series analysis before the presentation, I was wondering if somebody asked me this question and what am I going to say? I think I might take this into consideration and use a year before and a year after and see if that makes more sense. So thank you for asking me. It makes me think that what I was thinking was relevant. So next question is, thank you. Nice presentation is from Marcella. I'm curious about the regression analysis. Could you please talk a bit more about it? What variable you plan to consider? And what would be the data unit of aggression, census tract neighborhood? Yes. I am thinking of using, of course, the crime with within the census tract with the socioeconomic factors such as poverty or the race or ethnicity or employment. So that's the kind of variable I was thinking of using with for regression analysis. Does that answer, Marcella? Okay, thank you. Thank you.
I had a question for you. You
Yes.
talked about one of the challenges being the fact that the data gives you the time that the crime was reported as opposed to when the crime occurred. Do you have
Yes.
any idea to what extent those times are different? Well, is this something that's common in crime data? And is there anything in the literature maybe that has looked at how much of a difference there is in those times? Or is there anything in the data that you're working with that would allow you to explore that problem yourself?
That's a very good question, James. I read literature. Again, I did not include it in there because it's a very, very old literature. It's a violence in Washington, D.C. And the data that's used in there is specifically to the time. But this project or research report was done by the law enforcement agency. So that data was provided to them. So by looking at that data, I contacted the Washington Police Department and their GIS department. And one of the gentlemen got back to me and he says that the data that we have is all available online. However, you can contact Sutterson to see if you can get more data. Is it common to see? Yes, it is very common to see. Okay, let me go back to your other question. You asked me, how is it different when I said that to the time? It means, say I'm a police officer and a victim comes to me, says, I have seen a homicide or a shooting happen. The shooting happened perhaps 2 hours before when I'm recording it into the system. So that is the difference. And the way police officer is recording is based on their shift. So their shift might have been evening shift. So they recorded the offense by their shift, and the date and the time is recorded as a one variable or as a one field into the table. So it's hard for me to take them apart or create my own list of data, which will be very difficult if I have to do for 4,000 incidents, if it answers what you were asking.
Yes, so I think that volume would certainly be a lot of work. I didn't know if potentially you could dive into a small sample of the full data set and get some sense of, I didn't know if there's information available in the data that would, tell you when the crime actually occurred, and then you could make comparisons to when the crime was recorded. Didn't know if that was possible or not.
Yeah, that was quite frustrating for me because before I picked Washington, D.C., I was leaning towards Chicago because Chicago's data, crime data is one of the best out there because majority of the studies done in the US, like if you go research for a lot of the literature is done on Chicago, like 20 years from now. So, which is good because it gives us the understanding. But I talked to my advisor, Gregory, and he, helped me figure out that I should pick Washington, D.C. And I'm glad that I did because it makes me understand more about data that I did not before. So.
Good. Well, regardless of that problem, I'm sure you'll still come up with a lot of valuable insights when you're all
I
done.
hope so.
Any other last questions for Pallavi? All right. Well, thank you for a very interesting presentation. Good luck on your project.
Thank you so much, James.
And that brings us to our final presenter for the Spring 1 term, Rachel DeMarco. Rachel's going to talk to us about manatees.
Okay. Hi, everyone. Can you hear me okay?
Yes, I can hear you.
Awesome. Okay. And can you see my presentation?
Yep, looks good.
Great. So my name is Rachel DeMarco, and I'm going to be doing my capstone project on predicting impacts of water quality on manatee mortality in Florida. And my advisor for this project is Dr. Brandy Gartner. She's been super helpful in giving me advice so far, and I'm sure she will continue to after 596A. And since I am the last project, I'll try to leave off on a positive note as best I can, as this topic is a bit sad. So during my presentation, I'm just going to give a little bit of the background on manatees and water quality in Florida, what those two have to do with each other, and then go into my methods, what analysis I'm going to do, my anticipated results, and my timeline. So the West Indian manatee is an herbivorous marine mammal that lives in the Western Hemisphere. Its range extends from the east coast of North America down to about central northern Brazil. And the West Indian manatee can be divided into two subspecies. One is the Florida manatee, whose range is primarily around Florida and in North America. Whereas the other subspecies, the Antillean manatee, is more throughout the Caribbean down into South America. And for the purpose of my project and presentation, I'm going to be focusing on the Florida manatee, and we'll refer to it just as the manatee. Other things to note about the manatee is that they like warm, shallow waters. The warm waters help them regulate their body temperature, and the shallow waters provide them with food such as seagrasses and other aquatic plants. And they can be found in coastal waters. They'll travel inland in fresh waters and occupy brackish waters as well. They also have a long life history strategy, which just means that they take a couple years to reach maturity. And when they do reproduce, they typically only have one calf at a time. So this just plays a part into kind of the vulnerability of the manatee, as they do take a long time to reproduce. So specifically manatees in Florida, this map kind of gives you an idea of where you can find higher manatee concentrations. So we see high concentrations around Fort Myers, in the St. Johns River near Jacksonville, as well as areas in the Indian River Lagoon, which is on the east coast of Florida. You see some red spots there. It is important to note, though, that these concentrations are variable. During the warmer months, they tend to spread out more, whereas the colder months, they can be found more grouped together, trying to occupy warmer waters, potentially warmer inland waters. A bit about manatee protection history. In 1970, there was only a few hundred individuals left in Florida, and they were officially classified as endangered under the Endangered Species Act. And if you're unfamiliar with kind of how animal species can be classified for extinction risk, the chart on the right kind of gives a good description of how they're classified. So being endangered, they're at significant risk for extinction, and they're under the threatened categories. Around the same time, I believe in 1972, the Marine Mammal Protection Act was created, which also helped to provide extra protections for marine mammals and manatees specifically. They classified the manatee population as depleted, which essentially means that their population was almost no longer functional in their environment, or that they didn't have enough individuals to reach more sustainable levels. So at the time, the manatee population was in pretty critical condition. Later in 1996, the International Union for Conservation of Nature classified the West Indian manatee endangered globally. So both of the two subpopulations that I mentioned earlier, which on one hand is not a good thing because the large majority of the population was at risk for extinction. However, this brought more international acknowledgement and hopefully encouragement to protect the manatee instead of it just being federally. Moving forward to 2016, there was an estimated 8,810 individuals, which is really great. That's a huge increase from the previous 1970s few hundred individuals, and brought it up quite a lot. And the chart on the right here is from aerial surveys that started in 1991, and the data goes to 2019. So essentially, they're just counting individuals that they see Typically, they do this during the winter time when the manatees are in more concentrated areas. And so you can even see from the surveys, it's increased quite a lot. And so this new population estimate in 2016 led to the reclassification of the manatee as vulnerable. So moving up from endangered to vulnerable, which is really great, right? We're moving away, the manatee's moving away from extinction risk. And there was some criticisms. However, people thought that the manatee population still wasn't good enough to reclassify, and that moving them up from endangered to vulnerable would kind of take eyes or priority away from them. But it is important to note that they still receive all protections under the Endangered Species Act, even when they're classified as vulnerable. So we see populations increasing, but unfortunately, in 2021, we saw the greatest number of manatee deaths that have been recorded at 1,100 individuals. And when you compare this to the 2016 population estimates, that's about 12% of the population. So a huge, huge percentage of the manatee population passed just in 2021. And if you're looking at the chart on the right, this is recordings of manatee mortality since 1974 up until 2021. However, those recordings with the data that was available to me ended in May. So that doesn't include all of the counted deaths there. So what is contributing to manatee mortality? Some common causes of death include watercraft strikes, cold stress. Like I said before, they do rely on warm waters, and when they don't have habitat available to them for warmer waters, this can result in death. And also harmful algal blooms, which have become a more and more pressing issue in Florida and has been increasing over the years. And so I'm going to touch a little bit about water quality and harmful algal blooms now. So in the early 1900s, there was an effort to kind of change the hydrology in Florida. And part of this issues that people were encountering in the early 1900s have to do with our wet and dry seasonality that we have. So in the warmer months or in the summer months, we tend to get a lot of rain, which caused a lot of flooding and didn't allow people to establish agricultural areas in urban areas. And then during the drier months in the winter seasons, there wasn't enough water to sustain those agricultural areas. So in 1948, the Central and South Florida Project was established to help create things like canals, levees, and water pumps, and to better regulate the water movement in Florida. While this helped to establish more agricultural areas in urban environments, it led to some problems with how water was being moved and ultimately water quality. The picture on the right, you can see in A is historical drainage flow of water that generally just flows south from the Kissimmee Valley into Lake Okeechobee, which is right in the middle there, and then down into the Everglades. But after this implementation of the Central and South Florida Project, you had more water moving east through the St. Lucie River and Canal, and west through the Caloosahatchee River, and less movement southward towards the Everglades. And so in the 1990s, there was some outcry from the public and scientists and researchers that this change in water movement has caused water quality issues in Florida, such as increased harmful algal blooms in the east and west coasts, as well as impaired water flow to the Everglades. And so in 2000, the Comprehensive Everglades Restoration Plan was created. And this is a multi-billion-dollar project, both with federal organizations and state level organizations to help restore some of the historical water movement in Florida, to ultimately restore some of the ecosystems that have been impaired and just help protect those ecosystems better. So water quality and manatees. So one of the things that has been contributing to manatee mortality is harmful algal blooms. And Florida experiences some different types of harmful algal blooms, such as brown tides, which have been more common on the East Coast. We also get some freshwater blooms like cyanobacteria blooms. And the big one that most people hear about and is often talked about is red tide, which has been very common and intense on the west coast of Florida. And part of the reason for this is because red tides produce brevetoxins, which are a neurotoxin that can be inhaled or ingested. And this has caused fish die-offs. It can kill manatees, sharks, other marine mammals such as dolphins, and things like sea turtles. And so this has been really impacting the ecosystems, especially on the West Coast. And not only does it directly impact manatees, it has also been influencing die-offs or seagrass die-offs. So when we have these blooms, they can impair light penetration to the benthic habitat where seagrasses grow. And without light, seagrasses ultimately die since they do need light for photosynthesis. And what these things have been leading to, in addition, are manatee starvation, which has really impacted the East Coast populations of manatees and has been impacting the West Coast as well. So specific influencing variables of water quality concerns. And it really is like a multifaceted problem stemming from a lot of different areas that we can kind of group together and call urban and agricultural runoff. So specific things like nutrients, excess phosphorus and nitrogen, both organic and inorganic, has been contributing or has been leading to increased harmful algal blooms. It is important to note that harmful algal blooms are a natural occurrence, and it is a really complicated process and is slightly poorly understood how they do occur and how they are entirely affected, but it is suspected that nutrients are playing, or excess nutrients are playing a big part into that. Another factor is light availability, light for seagrasses, light for those harmful algal blooms, maybe decreasing light penetration. Also, general turbidity in the water can also impair seagrass growth. We also have temperature and pH, which are big ones when we think about climate change, right? Increasing temperatures are influencing or increasing harmful algal blooms, which also might impair seagrass growth, as well as imbalances in pH. And imbalances in salinity can also impair seagrass growth. And so some of these factors are coming from inland sources like agricultural fertilizer. Sewage is a big one as well, especially leakage from septic tanks is big on the East Coast as well. Fertilizers from golf courses, really big here in Florida. We have a lot of golf courses, as well as some other areas that these variables can be coming from. So why do we want to predict manatee mortality? Manatee population can be really reflective of how well a habitat or ecosystem is doing. You can think of manatees as keystone species, or they're telling of habitat health, right? So if we have areas that we're able to identify where manatees might not be doing well in the future or in now, then we can get an idea of how well that habitat is doing overall. We can also use it to assess the effectiveness of management strategies, both specific manatee management and water quality management, right? So if in the future manatees are still being predicted to high mortality, right, are things like the comprehensive Everglades restoration plan doing well enough? Are they really achieving their goals that they set out to do? And how can that maybe be improved to improve the habitat and manatee mortality outlook? And ultimately, we want to preserve them from extinction so that future generations can really enjoy the manatee. One of Florida's biggest economic drivers is tourism, which does largely stem from our ecosystems that we have and the nature that we have, the beaches, the Everglades, and things like that. And so we want to keep the manatee around so that we can, one, continue with that revenue, and also so people can come here and enjoy the manatee. So ways to predict. We can find historical and current patterns in manatee mortality, whereas manatee mortality decreased or increased, or what are the different trends that have been happening over time and across Florida with the manatee. And we can use emerging hotspot analysis for that. And then we can find future manatee mortality patterns. So what will manatee mortality look like in the future? What areas do we need to focus on in the future? And why might this be happening or being predicted to happen? And we can use random-based forest forecasting for that. So just to dive a little bit more into my methods. So I'm going to be doing a time series analysis. It's going to be kind of in 3 parts. The first part is constructing the space-time cube, which is the data structure that will hold my manatee mortality information and water quality information. And you can see the cube on the right there. And each column is a location over time. In my study, my locations are going to be watershed subbasins. And each block within the column are a time step. And in my case, it's going to be a year. And within each block, you have the data that will be aggregated or averaged. Or I'm thinking that I'm going to average them within each block at the moment. So then for my actual analysis, I'm first going to be doing that emerging hotspot analysis to determine clustering over time in space, right? What are areas that are seeing manatee mortalities? How has this changed over time? Maybe we'll see areas that once experienced a lot of manatee mortality, but is now experiencing less manatee mortality. And then using forest-based forecasting to hopefully predict future areas that will be experiencing it. The data that I'm going to use for manatee mortality is going to be coming from the manatee carcass recovery locations from the Florida Fish and Wildlife Conservation Commission, which has important attributes such as cause of death, location, and date. They specifically have a category for cause of death that includes harmful algal blooms that they point out, which will be of interest to me. And then my water quality data is going to come from the water quality portal, which sources data from EPA, USGS, and USDA, and will occasionally take data from other like researchers and people working with water quality data as well. And that will allow me to choose the variables that I'm interested, which I touched on before, such as the various forms of nitrogen and phosphorus. Things like turbidity, temperature, salinity will be of interest as well as the location and date. So a little bit about the emerging hotspot analysis. It uses 2 main statistics to show different trends, one being the Geddes-Ord GI starred statistic, which evaluates a variable within a neighborhood, right? So manatee mortalities at one location or one watershed subbasin versus the watershed subbasins around it at a point in time. And then the Mann-Kendall trend test to determine if events are increasing or decreasing over time. And those 2 combined, you get a lot of really interesting different types of trends that you can see kind of described on the right there for the hot spots. And then it also shows cold spots in blue. So hopefully it will result in really telling information of manatee mortality over time. And then a little bit about the forest-based forecasting. And this is a data-driven model that uses machine learning to essentially look at the data that's provided and randomly select subsets of that to create this forecast model to predict into the future, predict time steps into the future. And part of that is that essentially the model holds back some data that's provided, typically around 10% of the data. And so later on, after the model is created, it can then compare the forecast model to the data that was held back in order to validate on how well the model predicts into the future. Because if you can predict information that you already have well, you can kind of assume that it's able to predict pretty well into the future. So for my anticipated results, I'm expecting urban areas as hotspots for manatee mortality, especially associated with poor water quality due to urban runoff. I'm also expecting the estuaries of the Caloosahatchee and St. Lucie River to be hotspots, again, just from urban and agricultural runoff and issues from things like septic tanks. And I'm also predicting future population declines and essentially how much longer we have with the Florida manatee based off of the estimates or based off the data that we have right now. I would more so like to see that future populations are going to increase in the future instead of decline. That would be a really great and positive result. However, time will tell and the model will tell. So why do I want to predict? Why do people want to predict? I mean, we, Florida, the United States, and people across the world have put years of effort into the conservation for manatees. It's not just me, it's not just people in Florida. And as a previous science educator, I know firsthand how passionate people really are about it. And along with that, we've put a lot of money and effort and resources into preserving Florida's manatee and Florida's unique ecosystems and organisms. So why would we want to let that go to waste? And we should be very prepared to know what future manatee populations are going to look like in order to better manage them and better prevent future population declines. A little bit about my timeline, finishing or doing my proposal presentation today. And I'm thinking about presenting my project at the South Florida GIS Expo at the end of August. And so between now and then, I plan to create my space-time cube, complete my analysis, hopefully have a paper draft and my abstract submitted by June 15th, hopefully earlier, and just be ready a month in advance for the expo. I'm also thinking about possibly publishing my project and writing a paper, but I have less information about that. Thanks again to Brandy for all the help that she's really given me on this project and all the insight. It's been super helpful. And thanks for listening to my project.
All right, thanks, Rachel. Nice job. Looks like you've got a couple questions in the chat box already.
Referring to an earlier slide with the graph of annual mortality counts, there were 4 or 5 years that were extremely high. Is there any explanation for those years? Is that possibly an anomaly in the data? Thanks for your research on this topic. So there has been some like you could call them anomalies with manatee mortality. More so, it's been happening kind of more recently. Since 2020, there has been an unusual mortality event that's been happening on the East Coast that I kind of like briefly touched on, and part of that has to do with manatee starvation, unfortunately. The Indian River Lagoon on the East Coast is a pretty large manatee habitat and historically has had really large, extensive seagrass meadows. But in 2020, they saw 96% decline in the seagrass. And so they were having really high rates of manatee mortality there, which was unusual, but due to that seagrass loss, to the point where they've been actually feeding the manatees to help sustain their population. I'm not so sure about specifically some of the other years besides that. It could be from increased watercraft strikes for whatever reason that was happening. It could be due to things like harmful algal blooms or just less predictable events like that. Hopefully that kind of answered your question. I don't have like a very specific answer for those few years. Hi, Rachel. Great presentation, no question, but Carrie has Tampa Bay Water Atlas has great seagrass monitoring program. That actually might be really useful. I'll definitely take a look at that. Thank you for sending me that link. Do you know how hurricanes may affect the mortality rate of manatees? So from what I know and I've read is that there's not a lot of specific data or information about manatee mortality that have been impacted by hurricanes. I think partly just due to sometimes the inaccessibility or like the focus may not be on manatee mortalities, especially in more intense hurricanes in Florida. So I think that the best answer to that is researchers and people just aren't entirely sure. The manatee is such an iconic species in Florida. The public really wants to know their status and how they can help. How will you get your information to the public at large? Is that something you've thought of? That is a really great question. And it's actually something that I haven't entirely thought of. But it's probably something that I should think of and put in effort to kind of help bring this information to light. I previously have worked in some museums that I would be interested in probably reaching out to, or maybe just some other organizations that do public outreach programs and maybe providing them with some of the data I found, or even maybe creating like a story map for them that they might find useful in their education practices, or even just, I guess, for the general public to look at if they wanted to, or even reaching out to the Save the Manatees Foundation. They might be interested as well. Yeah, and it's like Brandy said, it's possible that the attendees at the conference may have the general public, because I do believe the conference that I'm intending to go to is a free event, so no one has to pay to attend it, which doesn't mean a lot of people will attend it, but it would be nice if a lot of people attended it, right? That'd be cool. Yeah, manatee is like the Florida's panda. It is, the manatee is very special. I think that was all the questions, and I really appreciate the questions. Those are helpful things to think about.
Okay, does anyone else have questions for Rachel? Yes, thanks, Rachel, for sending your contact info, your email address. I neglected to mention that the other presenters, if you're still on, if you could share your information. Thanks, Pallavi. That would be great in case anyone has follow-up questions or comments for them later. Okay, well, that wraps things up for today. As always, this was a really good set of engaging talks across a wide range of topics. Just a reminder, please fill out the peer review form for today's presenters. I posted the link again just before Rachel's presentation. Thanks for attending, everyone, and best of luck to all of the 596A students on completing your work and finishing your degrees. Take care, folks.